Hello everybody, my name is Ankur Srivastava and in this video I will be discussing the research contributions from my PhD thesis entitled The Indian Summer Monsoon Exploring the Role of River Runoff. The monsoon system is the lifeline of Indian economy and affects the lives and livelihood of millions of people residing in the country. It can lead to devastating floods and droughts, but at the same time bring a smile upon the faces of hardworking Indian farmers. Therefore, accurate forecast of monsoon rainfall is of vital importance. Hence, we use climate models for forecasting the rainfall. What is a climate model? A climate model is a set of mathematical equations that represents the various components of the Earth system, such as the atmosphere, ocean, and the land, etc. The question is, how do we improve these climate models for better forecasts of the Indian monsoon? It can be done in many ways. For example, I can include the representation of some physical process which were earlier missing from the model. Therefore, in my research, I address the physical processes which were missing from the climate model. The research hypothesis itself is quite simple to understand. Consider a column of ocean water. We all know that the temperatures decrease as we move deep into the ocean and the salinity increases. Due to the turbulence at the ocean surface, the upper few meters of the ocean is well mixed, which is sometimes referred to as a mixed layer. If we add fresh water to this mixed layer, which may be from rains or rivers, it affects the ocean salinity. Due to the changes in salinity of the upper mixed layer, the mixed layer thickness decreases and a new layer is formed, which is called the barrier layer. This barrier layer prevents the mixing of the water in the mixed layer with the deeper and colder subsurface ocean. Now consider if we heat this upper mixed layer due to the incoming solar radiation. It will lead to the warming of the sea surface temperatures and the mixed layer. And warm sea surface temperatures give rise to convection, which is nothing but vertical motion of air parcels containing moisture. As the air parcels rise in the atmosphere, the water in them condenses due to the decreasing temperature of the surrounding air, thereby forming clouds and causing rainfall. Now, when it rains, it closes this feedback loop between the freshwater and convection. Now, these processes are especially important in regions such as the Bay of Bengal, which has very low salinities in the northern part due to the heavy rain and freshwater received from major rivers such as the Ganga, Brahmaputra, and Irrawaddy. The climate model used by the Indian Meteorological Department to generate operational seasonal forecasts of the Indian monsoon did not have a representation of rivers. So I added a dynamical routing model to close the land surface hydrology. The question is, how do we represent rivers in these models? We can do this by the way of taking the global topography, which is nothing but elevation from the surface. This topography is used to identify river basins globally, and a flow network which is developed from this topography is generated. When the runoff generated by the land model is passed through this flow network, it gives us the river discharge at the land ocean boundaries. When we include the representation of rivers in this manner in our model, various interesting changes to the characteristics of weather systems occur. What is the monsoon? Monsoon is nothing but a manifestation of the northward propagating cloud bands from the usual equatorial position to the northern parts of the country. On the way to the northern landmass, these cloud bands pass over the northern Bay of Bengal, which houses the shallow mixed layers. The, prop, the proper representation of river freshwater in the northern Bay of Bengal causes realistic northward propagation of these cloud bands and the organization of rainfall and sea surface temperatures. The monsoon system also comprises of various low-level cyclonic circulations. These systems form in the northern Bay of Bengal and travel northwestwards, thereby bringing rainfall to the parts of Indian subcontinent. These systems usually have a lifespan of 3 to 6 years. Now, the inclusion of rivers in the model has led to a better representation of these systems, where the lifespan of these systems has increased and the rainfall associated with these systems over the Indian landmass also increases. Now, when we use this model to create seasonal forecasts of Indian summer monsoon rainfall for a long period of 1981 to 2017, we notice that the new model provides better forecast of the Indian summer monsoon compared to the older model. The interaction between the monsoon systems at different time scales, which is from days to weeks to months, has improved in the model. And the better seasonal forecasts are of vital importance for the economy and people of India. Thank you.